All right, our next lesson is about vectors. This one's going to be short. It's just a couple properties that I have to explain. First of all, let's take 2 points. Point A, which has the coordinates x and y, and point B, which has the coordinates alpha and beta. Vector AB is going to be formed by taking the x of the b, which in this case is alpha, and from it subtracting the x of a, which in this case is x. So x of AB is alpha minus x, and y is the same thing, b minus y. We know which one to put first based off of the second one in the vector. So if it's vector BA, you subtract x of a from, you do x of a minus x of b. But if it's vector AB, these are vectors, then you take x of b minus x of a. Here's an example of that. Actually, no, before that, I'm going to explain how to find the magnitude or the length of the vector, the line. It's really simple. You just take the x of the vector and the y of the vector, you square them, you add them to each other, and then you do the square root of that. So the distance would be the x of the vector squared plus the y of the vector squared. Really easy. Formula, you just need to know it. So here's an example. You have point A, which is 2, 3, B, which is 7, 5. So the vector coordinates of this are going to be, because vector AB, which means we start with the x of b. So 7 minus 2 is 5, and 5 minus 3, 5 because it's the y, and 3 because it's the y, is 2. So the vector coordinates of vector AB are going to be 5, 2. Now, the magnitude or the distance of vector AB, you just square the x and y like I said, so 5 squared plus 2 squared, and you square root them, like you radicalize them. So 5 squared is 25, 2 squared is 4, so 25 plus 4 is 29. So 29, I just wrote root 29, but you can also plug it into the calculator and get 5.385 something. But it's easier to just keep it as radical 29. And then whatever unit is used, if they don't give you a unit, then you would just write units next to it. And then also the vector coordinates of vector AB can be written as 5i and 2j. How do we know how to write those? I is how many x's it moves, j is how many y's it moves from the original. So this one moves, let me use a different pencil. This one moves 5 to the right and 2 up. If the coordinates were minus 5, then it would be minus 5i because it would move 5 backwards and 2 up. On to some properties with vectors. The first property is dot product, which is also known as scalar product. If you have 2 vectors and the dot product of the 2 of them is going to be equal to the x of the first times the x of the second plus the y of the first times the y of the second. Masalan, you have these 2 vectors, u with the coordinates AB and v with the coordinates CD. U dot v, or times v, would be AC plus BD. Now here's something important to remember. If the dot product of 2 vectors is 0, then those 2 vectors are perpendicular. They form a 90-degree angle between them. Now on to some triangle properties to know. Say we've got this triangle, ABC. First thing, the dot product of AB times AC, you can solve that however you want to solve it if you can find the vectors. If you don't have the vectors, what you can do is half, so half into AB squared, so the length of AB power 2, plus AC squared, so the length of AC power 2, minus BC squared, so the length of BC power 2. So that is one property or formula that you need to learn. Another one is CB squared is equal to AB squared plus AC squared minus 2 times the length of AB times the length of AC times the cosine of A. Now you might ask, how do I know what angle I need to use for the cosine? Look at this. You're trying to find length of CB, right? CB, well, CB's here. So the angle that the angle that we use for the cosine is the angle opposite to it. Okay, and then the last property is the median property. It happens if you have the median in a triangle. Pretty easy. It's MA squared plus MB squared is equal to 2MI squared plus AB over 2. AB squared over 2, sorry. So yeah, that is vectors, and you're welcome to, of course, take a picture of these properties because they're ones that are important.